Okay, this is our last calculation of a normal probability, and this is looking at probability by differences from our normal distribution on page 32. So we've got our backpacks example with our mean of 3.3, standard deviation of 0.3, and we're looking at what's the probability it weighs between 2.7 and 3.1 kilograms. So as always, our first step is to draw our distribution with our mean of 3.3. Now we're looking for a backpack weighing between 2.7 and 3.1. So both of those numbers are to the left of the mean, so they're both below the mean. So I'm just going to put 2.7 here, and then above that somewhere I'm going to put a value of 3.1. And we want to find the area between those 2 points. Okay, so that's what it is that we're trying to do. So if we're going to convert that to our z value, we've got to find both of those z points. So there's our mean of 0. We've got some value below and some value below that. So that's what we've got to first of all find, is those two z values. So we're going to take our formula, z equals x, take away the mean over standard deviation. And for the z1, we're going to say 2.7, take away 3.3 over 0.3, and that's going to give us a z-score of -2. So if I rub out that first question mark there, we can now put that value of -2 onto our distribution. And I'll just colour that area in to remind us that we're finding the area between those 2 points. Now we're going to find our second z value. X, take away the mean over our standard deviation. So our x value is 3.1, so we're going to say 3.1, take away the mean of 3.3 over 0.3, and that is going to give us a z-score of, I'm running out of space here, of, let me just put it up here, -0.667, which again I'm doing that to 3 decimal places because that's what our calculator is going to do. Oh, sorry, yeah, our tables need to go to 3DP. So then I can again rub out that second question mark, and now I can put in that value of -0.667. Okay, so let's think about what it is that we'd get from the tables. We know that it's symmetric, so we can flip this around and say that if I go from positive 0.667 up to the value of 2 and look at that area between the positive values, that should be the same size area as the negative value that I was looking at before. Okay, the difference is just one's below the mean, the other's above the mean, but the values are exactly the same. Then we can think, well, on the tables we can find from that mean of 0, we can find the area between 0 and 0.667. So we can find this area between those points. We can also, from our table, find up to the value of 2, we can find that total area up to there. Okay, and what we really want to do is we want to find the difference between those two. Okay, so the area that we're trying to calculate, this, oh, let me do that better. This area that we're trying to find up the top there, we could say is equal to this whole area here between 0 and 2, take away the area between 0 and 0.667, and that will leave me with the area between the two. So let's find those areas. So if I look up that probability from, oh, not that one, undo that, going between 0 and 0.667, then that is going to give us a value of 0.2 0.2473. And if I look between the z value of 0 and 2 and find the probability of this area, that's going to give us a probability of 0.4772. So now I'm going to subtract those two areas to find the one that I want. So let's write this down properly with our notation. The probability of being between 2.7 kg for our x distribution and 3.1 kg is equal to the probability of being between negative, let me get this the right way around, of negative 2 and from z and negative 0.667, which is also, we're doing the that's when we flipped it around. So this is when we flipped it around to the positive value. So that means it's the same as the probability of being between negative or positive 0.667 and 2. Oh, undo that, and 2. So that's what we're doing. And we know the probability of being between 0 and 2. And we're going to subtract from that probability the probability of being between 0 and 0.667. So that's going to give us our probability of 0.4772, take away 0.2473, which gives us an answer of 0.2299. So we found a difference because we're subtracting the difference, and then we write a sentence saying that the probability of our backpack weighs between 2.7 and 3.1 kg is equal to 0.2299.